A0. I am here to give presentation on energy efficiency and consumption. So we will be going to introduction for energy efficiency and conservation, clean energy technologies, applications of clean energy technologies, importance of clean energy technologies, sustainable development. So energy efficiency refers to using less energy to perform the same function. For example, LED bulb provide the same brightness as incandescent bulbs, but consumes less electricity. Efficiency focuses on maximizing output while minimizing energy. While energy conservation refers to reducing overall energy consumption by adopting habits or technologies that prevents unnecessary energy use. For example, turning off gas and turning off lights when not needed, or using public transport instead of personal vehicles. So, by integration is important. So, integration with energy resources. Energy sources. Both efficiency and conservation is applicable to energy, renewable energy sources and non-renewable energy sources. Need for energy efficiency and conservation. First, rising global energy demand. The world's population and industrial activities are growing, leading to increased energy consumption. Efficient energy usage ensures to make demand without excessive resource depletion. Depletion of fossil fuels such as coal, oil, and natural gases or renewable and will eventually run out. Energy conservation helps slow down their depletion while alternative energy sources are developed. Environmental effect. Excessive energy use leads to pollution, habitat destruction, and energy and resource depletion. Conservation reduces these negative effects. Climate change. Burning fossil fuels releases greenhouse gases, contributing to global warming. Energy efficiency reduces emissions and helps combat climate change. Economic benefits. Lower energy consumption translates to reduced costs for individuals, businesses, and governments. Energy conservation practices. Simple steps like turning off unused appliances, using energy efficiency lighting, and optimizing industrial processes can significantly cut energy wastage. Support for renewable energy. Efficiency and conservation complement renewable energy sources, promote sustainable development and future energy security. Next, clean energy technologies. Renewable energy system, solar panels. Solar panels uses photovoltaic PV cells to turn sunlight into electricity. Modern panels are designed to capture more sunlight and waste less energy during conversion. Wind turbines. These convert wind into mechanical energy, which then turns into electricity. Two designs improve aerodynamics, how air flows over the blades, making them more efficient and powerful even at the lower wind speeds. Hydropower systems uses the movement of water from rivers or dams to generate power. Advanced turbines and control systems help extract more energy from flowing water while reducing waste. Smart grids. Smart grid. It is assumed that smart grid as an upgraded energy system that uses smart technology to manage electricity distribution more efficiently. It uses energy loss during transmission and adapts in real time, meaning it supplies energy based on demand to avoid wastage. Energy efficiency. Ingredients. First one, LEDs. Use way less power than old incandescent bulbs and even CFLs. Smart thermostats. Sensors and AI to adjust heating, cooling, or even integration. And insulation materials. Special materials or special materials that helps keep buildings warmer in winter and cooler in summer, reducing heating and cooling costs. Industrial efficiency. Heat recovery systems. Instead of wasting heat produced in the industrial processes, it gets reused for heating or generating electricity. High efficiency motors and drives. It just says motor speeds based on demand, reducing unnecessary power consumption. Conservation technologies. To reduce dependence on fossil fuels, energy needs to be stored efficiently for later use. Batteries. Lithium-ion solid state. Store energy from renewable sources like solar and wind for later use, ensuring a continuous power supply. Flywheels. Stores kinetic energy and releases it when needed. useful in large-scale industrial applications and power grids. Energy monitoring systems. These systems help track and automate energy usage to prevent waste. IoT sensors. So IoT stands for Internet of Things. Devices that uses real-time energy consumption, identify inefficiencies, and helps automate energy use. Energy management software uses data analytics to suggest energy saving strategies and monitor energy use rates. Transport efficiency. This focus is on making transportation more energy efficient. Electric vehicles. Nowadays, we are seeing that we are using electric vehicles. Replaces traditional gas-powered cars with cleaner electric-powered alternatives, reducing pollution and fuel dependence. Regenerative braking. A system that recovers energy when braking and stores it for later use. Is efficiency. Alternative fuels. Biofuels made from renewable organic materials like plants, vegetable oils, or animal fats. For example, ethanol from corn or sugarcane and biodiesel is extracted from vegetable oils. Helps reduce carbon emissions because plants absorb CO2 as they grow while stop emissions when burned. Hydrogen fuel cells. This converts hydrogen gas into electricity, making it a powerful alternative energy source. The only byproduct is water, meaning zero pollution. These are used in hydrogen-powered vehicles, power plants, and backup power systems. Applications of clean energy technologies. First, residential. Rooftop solar panels converts sunlight into electricity for household use, reducing billions of fossil fuels. Smart home devices use automation like smart thermostats and lighting to save energy. Commercial. Smart HVAC systems automate heating, ventilation, and air conditioning to reduce energy wastage. Energy efficient office equipment devices like LED monitors and low power printers minimize electricity usage. Public infrastructure, LED street lighting, and solar powered traffic signals. These works independently from the power grid, reducing energy demand. EV charging stations supports electric vehicles adoption and reduce emissions from gasoline powered cars. Agriculture, solar water pumps using solar energy instead of diesel for irrigation. Efficient irrigation systems reduces water and energy wastage in farming. Biogas production converts organic wastage into renewable energy for cooking or electricity. So these innovations reduce energy costs, lower carbon emissions, and improve sustainability across different sectors. Importance of clean energy technologies in sustainable development. Clean energy sources like solar, wind, and hydropower help reduce negative environmental impacts and support sustainable development by minimizing pollution, conserving resources, and mitigating climate change. Environmental benefits of clean energy technologies. Reduction in greenhouse gas emissions. Traditional fossils release CO2, which contributes to climate change. Whereas clean energy technologies generate electricity without burning fossil fuels, reducing carbon emissions and slowing global warming. Decreased air and water pollution. Fossil fuels combustion releases pollutants like sulfur dioxide and nitrogen oxides, which causes acid rain and respiratory diseases. Renewable energy eliminates these emissions, leading to clean air and healthier ecosystems. Hydropower and solar energy also reduces water contamination from industrial waste. Conservation of natural resources. Fossil fuels are finite resources, meaning they will eventually run out. Renewable sources like sunlight, wind, and water are inexhaustible, ensuring long-term energy sustainability. This reduces dependence on coal, oil, and gas, preserving them for critical applications. Economic growth. Creation of green jobs. The shift to renewable energy creates new employment opportunities in various fields, such as solar and wind power installations, energy storage development, and energy efficiency projects. This transition helps diversify the economy and reduces reliance on fossil fuel-related jobs. Energy cost savings. Energy efficient technologies like LED lighting, smart HVAC systems, and better insulation helps reduce electricity bills for homes, businesses, and industries. Clean energy sources like solar and wind have low long-term costs compared to fossil fuels. Resilience in energy supply. Decentralized renewable energy systems like rooftop solar panels and local wind farms improve energy security by reducing dependence on imported fossil fuels. Social development. Improve public health. Clean energy sources like solar, wind, and hydropower do not release harmful pollutants. They fossil fuels related harmful gases. Energy access for all renewable energy systems like solar microgrids bring electricity to rural and undeserved areas. Access to electricity improves education, healthcare, and economic growth. Empowerment of communities. Communities. Locally renewable energy projects allow communities to manage their own energy resources, reducing reliance on centralized grids. Climate change mitigation. Mitigation refers to reducing greenhouse gas emissions to slow down global warming and its harmful effects. Clean energy plays a major role by replacing fossil fuels with sustainable alternatives like solar, wind, and solar. SDG 7. Affordable and clean energy. It promotes renewable energy access worldwide. Reduces dependence on coal, oil, and gas. SDG 13. Climate action. By reducing carbon emissions, clean energy helps combat global warming. It also supports climate resilience by reducing pollution and improving quality. SDG 9. Industry innovation and infrastructure encourages green technology innovation in industries. Technological advancement. Innovation and progress. Investments in clean energy lead to cutting-edge technological developments. Innovations results in more efficient, reliable, and cost-effective energy solutions. Integration with smart systems. Clean energy works seamlessly with smart grids, IoT devices, and energy management systems. Smart grid optimize energy distribution, reducing waste and improving efficiency. Conclusion. Clean energy technologies are key drivers of sustainability, helping addressing major environmental, economic, and social challenges. It just